Unit 3, Programming with Business Rules. This unit describes the rule engine and how rule execution works. It also describes the rule execution modes. After completing this unit, you should be able to describe a rule engine, describe rule execution, and explain rule execution modes and execution principles. We'll start with the first topic in our unit, introducing rule set integration and execution. The objective of integration is to make the decision service accessible to your enterprise applications and business solutions. Integration of ODM means that the business logic, which is embodied by the decision service, can be easily updated and made available in your execution environment, so that accurate, up-to-date decisions are returned to whichever business system, process, or device triggered the decision request. The steps for integration vary depending on your execution environment. So what are the integration steps? Well, basically they involve packaging, deployment, and execution. The rules and other artifacts that are authored in ODM tools need to be packaged into an executable container. The rules that you want to use in a decision service can be extracted from several rule projects and then packaged as a rule set archive. The packaged rules are then deployed to the execution environment. And once the rules are available in the execution environment, the client application can call the decision service to trigger rule execution. How the client sends execution requests will vary according to the business solution and execution environment. For the execution environment, you can either have the rule engine embedded or managed by using the rule execution server. Using an embedded engine is common when you're conducting local tests, but managed execution with rule execution server provides far more powerful features when you're running the application in an enterprise environment. Our next topic, what is a rule engine? The rule engine is a Java object that's used to evaluate and execute the rules. In this graphic, you see that objects can be passed in and out of the rule engine through rule set parameters. They can also be inserted into the working memory. You also see an agenda, which keeps the list of which rules need to be executed based on the rules that were matched against the objects. To process the rules that are passed to it in the rule set, the rule engine will evaluate each rule in the rule set against each application object. And when it finds a match, then it executes that rule. The rule engine can actually operate in 3 different modes: fast path, rete plus, or sequential. Fast path is the default. The selection of the rules and the order in which they are executed will depend on which execution mode the rule engine is running with. To better understand the rule engine, let's walk through the steps depicted in this graphic. In the first step, the rule engine compares each of the objects that's passed from the application to each condition in each of the rules of the rule set. The engine evaluates all the rules against every object. This process is called pattern matching. Every time there's a match between a business rule condition and an object or a group of objects, the rule engine creates a rule instance for step 2. In step 3, the rule engine executes the rule instance by completing the rule action. The execution mode that the rule engine is using determines how that rule instance is processed. When you define your decision service, you specify the decision engine as the rule engine type. A decision engine is an instance of the engine interface, and an application can actually contain several rule engine objects. You use the Decision Engine API to define the loading of rule set archives into an engine loader, which represents the result of compilation of a rule set. The Decision Server class library includes the packages that you see listed here for the rule engine. For more information about using the Decision Engine API, see the product documentation. understanding rule execution modes. As we've mentioned before, the possible execution modes are RETE+, sequential, and FastPath, with FastPath as the default. In the next part of this unit, we discuss these execution modes in detail. The FastPath algorithm is actually a sequential mode of execution, but like RETE+, it can also detect semantic relationships between rule tests during the pattern matching process. In FastPath, the rule engine can use working memory or rule set parameters. As in RETE+, FastPath also involves the pattern matching process, but instead of using an agenda, it creates a tree that is based on the semantic relationships between rule condition tests. For each match, a rule instance is created and immediately fired. When a rule instance is fired and the action is executed, it might modify objects in working memory, but as with sequential, these modifications are not taken into account to redo the pattern matching process. Because FastPath combines features of RETE+ for pattern matching along with features from sequential for rule firing, this algorithm can produce good performance for correlation applications as well as validation and compliance applications.